Hello class, today we are going to look at factoring a trinomial with a lead coefficient other than 1. There's a few methods to factoring these types of problems. One of the methods is the guess and check method, which is covered pretty heavily in your textbook. The other two methods are the bottoms up method, which is a video that I posted in that first response to the DQ question, and the AC with factor by grouping. So a couple methods to work with. We'll start with the bottoms up method, and I'll go through and show you how to do this process. So let's go ahead and start. Remember, you can always pause it if I'm going too quick for you. Okay, the bottoms up method asks you to check for GCF first. 3, 8, and 5, no GCF there. So I'm just going to write no GCF as a reminder that I checked. If you forget to check and there was a GCF, this process will not work correctly. So you always want to take the GCF out first. Okay, after you do that, we're going to take the A term, which is the number in front, and multiply it by the C term, which is the number in back. So A times C gives me 15. So that's my new constant. So I get x squared plus 8x plus 15. Okay, so this is my new trinomial that I'm going to factor. Notice that now we have a lead coefficient of 1, so it becomes a little easier to factor these. The way that I factor these is I figure out what two numbers multiply to give me the C term, which is now 15. And I want two numbers to add to give me the middle term. So add to give me that positive 8. So notice that we have positive 15 and positive 8. So I write down all the combinations for 15. 1 times 15. Negative 1 times negative 15. 3 times 5. Negative 3 times negative 5. What we're looking for is only one of these combination will also add to give us 8. So let's write down our possibilities and see which one works for us. You may see which one's working for us already. If you do, then you can skip ahead to that step and identify it, and that's probably what we'll cut down as you start to do more of these. You'll start to figure out which combinations work a little faster instead of writing them all down. Until then, we write them all down. 1 plus 15 is 16. That's not 8, so that's not our combination. Negative 1 plus negative 15, negative 16, not our combination. 3 plus 5 gives me 8. That's what I was looking for. I can check the last one, negative 3 plus negative 5 gives me negative 8. There's only going to be one combination that works, so once you find it, you can be done. So I'm going to go ahead and get my two binomials set up. Remember, we're undoing FOIL, so we're going to have two binomials here. The x squared breaks down into x and x. Now the numbers that go inside here are the numbers we found that works as our combination. So I found that a positive 3 and a positive 5. So that's a plus 3 and a plus 5. Now if we FOIL this out now, we get x times x is x squared, which is what we had here, but our main goal is to get back to this 3x squared. So we're not quite done. We still have a little work to do. What the next step is we look back and see what number did we multiply in. Well, in this problem we multiplied a 3 in. So I'm going to divide all the numbers I just came up with, the two factors, by that number 3. So this, what we're dividing by, is going to change depending on the original problem. Go ahead and reduce your fractions. 3 divided by 3, that's 1. On my second one, I have 5 over 3. Well, 5 and 3 don't reduce at all. It doesn't divide nicely. So what ends up happening is this is where I get that number in front of the x. So I move that 3 up and I keep the 5 where it was. Now our hope is that it's factored. the way to check is using FOIL. So let's go ahead and FOIL it. So x times 3x gives me 3x squared. X times 5 gives me plus 5x. 1 times 3x gives me plus 3x. 1 times 5 gives me 5. Combine my like terms, which is the middle terms. That gives me an 8x plus 5. Check back to my original. Looks good. So my factored form is x plus 1 times 3x plus 5. And the order doesn't matter. If you have 3x plus 5 times x plus 1, it would also be considered correct. Okay. So this is the bottoms up method. One of the methods that works. You just really want to be careful that you check for GCF first. Okay. Let's go ahead and look at the other option. This is the AC, which is factor by grouping. It's very similar to the one we just did. You're going to notice a lot of the same numbers popping up. Okay, so the first part is A times C. Remember, we have AX squared plus BX plus C. That's the A and C we're referring to. So A and C is 3 times 5, which is 15. Again, I skipped the step of finding the GCF, but we've already checked it on the previous problem, but we probably should write it just to make sure we remember we checked. Okay. So now 15. So again, I'm going through the process and I want to find what two numbers multiply to give me 15 and add to give me this middle term of 8. So you can see how some of the steps are the same. Notice how I didn't rewrite it as the 15 and back though. So let me go ahead and check for our combinations. We know that 3 times 5 gives me 15 and 3 plus 5 gives me 8. We've already checked that, so I'm going to jump to that step. Now here's the different part. The 3x squared stays the same. The plus 5 stays the same. But this 3 plus 5 replaces the 8x. So instead of a plus 8x in the middle, I'm going to have a plus 3x and a plus 5x. Okay, so I'm trying to find the combination that breaks up that middle term, and this is the process over here. Now the factor by grouping, here's where that comes into play. We're going to look at these first two terms and we want to figure out, do they have a GCF? If they do, we want to factor it out. Well, they definitely have a 3 in common, and they also have an x in common. So I factor out 3x, which leaves me with x plus 1. Now I check this second grouping. Do they have something in common? Yeah, they have a 5 in common, which leaves me with x plus 1. Factor by grouping, your goal is to end up with the same thing in both binomials. So notice I have an x plus 1, x plus 1. Perfect. So just like I was able to take a 3x out, and just like I was able to take a 5 out of these, I'm able to factor out an x plus 1 because they both have an x plus 1. Now here's the tricky part that sometimes gets missed, is my second binomial is going to be what I didn't use in each of these groups. So you see the 3x and the plus 5. Again, we've already foiled this in the last problem to check, so I'm going to give it a check that that's our final answer. But again, if you wanted to, you could foil just to verify. So those are a couple options other than factor the guess and check method, which is the book. If you are interested in something different, you are welcome to try these. You will continue to see factoring trinomials in the next few chapters, so I would suggest getting this concept under control. If you have any questions, feel free to contact me.